Okay, today we're going to, our learning goal is I can explain how scale factor can affect the perimeter and side length of a dilated figure, and I can explain how scale factor can affect the area of a dilated figure. So we're going to be talking about perimeter and area and how a scale factor affects the perimeter or area of a figure, essentially, okay? So here we go. Notes. How do you find perimeter of a shape? Yes, there are different ways to do this, but the easiest way for us to do this and know that it works for all shapes is to add all sides. So if you add all your sides, because perimeter is the first dimension, you are going around the outside edge. It's kind of like if you have a field, you're walking the fence line of your field out there, okay? You're walking all the way around. So if you, here, if this side is 4, I think by now most of you know that this side is 4. And if this side is 6, then this side is 6. And so then just to add them, you would do 4 plus 4 plus 6 plus 6, which when you put that in your calculator, you would get 20, okay? And it's 20 units, and perimeter, because you're only counting around something, it's in the first dimension. But remember, I keep saying we're lazy mathematicians, so we leave that off, all right? So when it says units, it's units to the first dimension, but we leave that one off. Just, you know, it's the way we do things because we're lazy, all right? So let's look at this one. This is a square. So now, what are your side lengths going to be? Well, yeah, they're going to be all 8s, aren't they? So 8 plus 8 plus 8 plus 8. Or you can do 8 times 4 if you'd like. That is 32. And remember, perimeter is the first dimension. So we can do to the first dimension, okay? But normally you leave it off. So that's what this indicates, that you're dealing with perimeter or only length of something. This length plus this length plus this length plus this length. You're not talking about how, let's look at how do you find area of a square or a rectangle. Well, fortunately for you, it is on your mathematics chart if you do not remember. And on my mathematics chart that I have right here, I have a bunch of things written on it, and we'll be getting to all this soon. But on the area of a triangle, it's 1/2 times little b times h. The area of a rectangle, which is what we are going to concern ourselves for this lesson, is its area equals little b times h, or you've known it as length and width, okay? So little b and h is your base and your height of your shape. So we're going to write a equals b h. And it's really b times h. When you have two variables next to each other, it means to multiply them. Just like when you have a number and a variable next to each other, it means to multiply them. So find the area of the shape. So all you're going to do here is 2 times 5 in your calculator, and you would find that that is 10. Now, square feet. So that is how we write feet squared, okay? And do you notice this 2 up here? This is indicating that you're in the second dimension, because what we're talking about, when we're talking about area, we're talking about what is all of this inside your dimension, your lengths, okay? So we're talking about the area inside the lengths when we're doing area, and that's why it's to the second dimension, okay? So here we go. We've got a square, so we would just use 7, and obviously this side is 7, so it is 7 times 7, which is 49 inches squared, because you're in the second dimension. Now, you need to know something, because this is going to become very, very important in our next, well, in the next couple of weeks here. When you have a square, it's never been taught to you, because you've always known length times width or base times height. But really, essentially, it's side times side, okay? Which can also be written as side squared, now that you know what squared means, okay? So if you, and why this is going to become important is because in Pythagorean theorem, we're going to be having to find the side length, and so you have to break apart your square, all right? So side times side, so if this was 7 times 7, which is the same as saying 7 squared. And when to undo a square, you take the square root, and it would give you the side length, okay? Each dimension of the new triangle is 3 times the side of the original rectangle. So they're telling you that the scale factor is 3, okay? So your perimeter of this figure, remember we're going to put this is the same as this, and this is the same as this, and when they have these marks, it means this one should have 1 and this one should have 2, which indicate that they are the same, okay? So we need to find the perimeter, so we would add them. The perimeter is 3 plus 3 plus 2 plus 2, and you can do that in your calculator very easily, and you would find out that that is 10 centimeters, okay? The area, all you're going to do is your length times your width, all right? So 2 times 3 is 6. So 2 times 3, which is 6 centimeters. And remember, this one is in the second dimension, okay? So we've got a scale factor of 3. So now we want to find the new. So this is the original, and this is the new. And I know it's not very well indicated on here, but that's what we mean, okay? So if we have a scale factor of 3, if you remember from your dilations practice, you take the original times the scale factor, but it's a little bit different when it comes to perimeter and area. So here, if you take your side length, 3 times 3, because that's what your scale factor is, your new side length would be 9 here, okay? And we're still talking about centimeters, all right? Then you do 2 times 3 to get this side, because it's 2 times your scale factor, which is 3. You would get it as 6, okay, centimeters, all right? So then this would be 9, this would be 6. To find your new perimeter, you would do 6 plus 6 plus 9 plus 9, and you would get 6 plus 6 plus 9 plus 9 in your calculator would give you 30 centimeters. On your area, it is 6 times 9, which is 54 centimeters squared, okay? Now, there's a much simpler way to do this, okay? If you know your original perimeter, think about it, 10 to 30, and we had a scale factor of 3. Well, the sides of the new figure are 3 times the original, okay, because we did times 3. The perimeter of the new figure is also 3 times the original. In other words, to go from 10 to 30, we basically just took that 10 times 3, and we got 30. Okay. The area of the new figure, 6 and 54. Well, we did it times what? 9. How does 9 relate to 3? Well, it's 3 times 3 gives you 9, doesn't it? Which 3 times 3, if we go back to that, is the same as 3 squared, isn't it? Oh, so now if you take the original area and you multiply it times 3 squared, because you're in the second dimension, you get the new area. So we are going to, so it is 9 times the original, or 3 squared times the original, okay? Because 3 squared is equal to 9. So here it is in a nutshell. The original perimeter, take the original perimeter times the scale factor, you get the new perimeter. You take the original area times the scale factor squared, you get the new area. So if you're looking for a side length, you just do it times the scale factor. If you're looking for perimeter, you do it times the scale factor and you will get the new one. If it's area, then you do it times the scale factor squared. So let's quickly finish this right here, okay? So perimeter, we're only going to talk about perimeter. Remember, perimeter, you're in the first dimension. So new perimeter is equal to old perimeter times your scale factor. Remember, that was our formula. Well, they want to know what the scale factor is here. So we're going to have to go back to what we learned with dilations. To find a scale factor, what do we use? Just say, hopefully you're saying just say no. Okay, new over original. If this is my original and this is my new, I have a side length of 12 here in my new. I have a side length of 6 here, which gives me 12 divided by 6, simplified, is a scale factor of 2. Okay? My original perimeter, I would highly suggest that you get used to writing everything on your figure. So 6 plus 6, and I'm going to do this the hard way, 6 plus 6 plus 3 plus 3, and what does that equal? 18. So my original perimeter was 18. My process step is to take 18 times my scale factor. So this is perimeter times my scale factor to get my new perimeter of 36. Okay? Now, perimeter, here we go. We got another one. So it's first we want the scale factor, and your worksheet looks just like this. So new over original. So I'm going to designate which one's my new, which one's my original. I'm going to do 6 over 12. Well, 6 over 12 simplified gives me, you can either find that it's the fraction 1/2, or you can use 0.5. Okay? In this case, when you're multiplying, it's probably easier just to use 0.5. Okay? So, original perimeter, remember I would have 12 here and I would have 8 here. So I would be doing 8 plus 8 plus 12 plus 12, which equals 40. The process steps, perimeter, original perimeter, so I'm going to put an O here for original perimeter, times my scale factor, which is 0.5. Make sure you leave lots of room so you don't get all these decimals and multiplication signs messed up. So 40 times 0.5 is 20 centimeters. Okay, we're in the first dimension. We're only talking about perimeter so far. Here's a test question. The high school football field has a regular field that is similar to the size of the middle school field. Isn't that a joke? Each dimension of the high school field is 4 times the corresponding dimensions of the middle school field. Which statement is true? So 4 times, so that's my scale factor, is 4. Okay? So, since I'm talking about perimeter, I'm just going to take my original perimeter times my scale factor, but they didn't give me my original perimeter. But remember, I take my original perimeter times my scale factor to the power of 1, don't I? So it's just 4 times. So when I'm talking about perimeter, it says the high school field is 16 times the perimeter of the middle school field? No. The area, see, we're not even talking about area here. They wanted to talk about perimeter, each dimension, which is a side length, okay? So it's either got to be this one or this one, and perimeter 16, perimeter 4, that's the one I want because the perimeter is the scale factor, 4 times larger. Okay? Then let's do this one with area. Remember your new area, the formula said you take the old area times the scale factor squared. Okay? So here we go. Original, new, or old and new. Remember, we're doing 3 times 2 because, well, they want the scale factor first, so let's figure it out. N over O. This corresponds with this, so 12 over 3. You got to have corresponding sides, okay? So new over old, 12 divided by 3 gives you 4. The original area, all you're going to do is multiply your sides. So I'm going to do 2 times 3, which gives me 6. And remember the process step? It is what? Original area times the scale factor squared. So I'm going to do original area, which is 4, times my scale factor, which is squared. So I'm going to put, oh, look at me. I did those backwards, didn't I? Now I got to fix them. Original area is 6. Scale factor is 4, because that would give you a different answer. Okay? So 6 times 4 squared, you put that in your calculator, and for those of you who don't know how to do that, 6 times 4 squared, and I get 96. Okay? Let's go back over here. Original, new, one more time. New over original for my scale factor. I have to use corresponding sides, so this one is the same as this one. So I'm going to put my new over my original. And yes, I can use 1/5, or I can change it to a decimal, which is so much easier. 1 divided by 5 is 0.2. My original area, remember this would be 10 times 5, or 5 times 10, which is going to give me 50. Process step, original area, 50 times my scale factor squared, 0.2 squared. So 50 times 0.2 squared, and I hit enter, and I get, ooh, look at that, 2. Ah, okay. The community soccer field has a rectangular field that is similar to the size of the city field. Each dimension of the community field is 9 times the corresponding dimensions of the city field. So your scale factor is 9. Which statement is true? So your perimeter would be 9 times bigger, okay? Your area is going to be 9 squared. So your perimeter is going to be 9 times bigger. Your area is going to be 9 squared bigger. And if you put 9 squared in your calculator, you find out that that is 81. So in order to figure out which statement is true, because they haven't told me if they're asking me about perimeter or area, I have to know both. The perimeter of the community field is 18 times. Well, no, it's 9 times. The area of the community field is 9 times. Well, no, because it is 81 times. The perimeter of the community field is 81 times? Nope. So the area of the community field is 81 times the area of the city field. There we go. And we're done. And if you'll look, you'll get up and go get your worksheet. It is very, very similar to what we just did. The front is all about perimeter. The back is about area. Have a great day.